Okay, today we're going to take a look at KK15, analyze a regression line of a data set. So what we're going to look at today is we're actually going to be given a data set, an X column, and also a Y column. And what we're going to do is we're going to come up with the equation for the line of best fit. And we're going to use a linear regression for that equation. So we're trying to get our answers in the form y equals mx plus b. But I'm actually going to show you how to use the graphing calculator to calculate what the rate is in addition to what the starting value is. So we're going to find out what m is for the rate and what b is for the starting value. All right, let's take a look at this problem. It says find the equation for the least squares regression line of the data described below. Stem and Leaf Agriculture wants to add a new compound to its bags of sunflower fertilizer. The company produced several bags containing varying amounts of the compound to see if it would affect sunflower growth. Next, Stem and Leaf collected data on the amount of the compound added to each bag in grams, X, and the weekly growth of the sunflowers treated with each bag in centimeters, Y. All right, so let's just take a look at the data. We see that when the compound was 4, sunflower growth 20. When the compound was 46, 25. 65, 31. 69, 35. 81, 34. Now, in general, just kind of looking at the data, you can see that as the value of X increases, for the most part, it looks like the value of Y also increases. You could see that the last one here had a slight decrease, but overall, most of the data seem to indicate that as the value of X increased, so did the value of Y. So what we're going to do today is we're going to find out the line of best fit of these 5 data points. Now remember, a point is composed of an X and a Y value. So we have 1, 2, 3, 4, 5 data points. Now, normally we use our graphing calculators, the yellow ones from class. Today I'm going to show you how to use Desmos to find the line of best fit. So first thing that you want to do is if you want to go to Google and just type in Desmos. Okay, now Mr. Denaxis actually had a tutorial about how to use the Desmos graphing calculator. I typed in Desmos on Google and I want to click on graphing calculator. Okay, so now I have my graphing calculator up. Now, again, normally we would show you how to enter in the data on the graphing calculators in school, but Desmos is kind of nice. Desmos will allow us to copy and paste the table into Desmos. So the way we're going to do that is we're going to go back to our IXL. And here's the data table. I'm highlighting the entire table. Okay, so again, to highlight, you're going to click, hold down, and scan your mouse over everything. Okay, once everything's highlighted here, you're going to double click and say copy, or another option is to do Control C. Control C is another way to copy on the computer. We're going to go back to our Desmos graphing calculator, and we're going to do Control V. Control V will paste the copied material into Desmos for us. If you want to make sure that it didn't make any mistakes, you could go back to the IXL. I'm just going to get rid of this other one that I had here. Okay, you could go back to IXL, see how we have 4 and 20, 46, 25, 4 and 20, 46, 25, and so on. What it did was it took the data for us, and if you actually take a look over here at the graph, you can see that it plotted those points. Just going to zoom out there a little bit. You can see that it actually plotted the data points for us. Here was the point 420 and so on. It has the other data points. You can see that there's 1, 2, 3, 4, 5 data points, which is what we had before. Okay. Now, underneath, you see how on Desmos it has a little 1 here? I'm not sure if you could see that. It's pretty small, but if you look carefully, you see the number 1 right there. And if you look carefully again, you could see the number 2 right there. Well, for Desmos, we could actually perform multiple operations at one time. So we have our data set in 1, and now I could click down here where it says 2, and I could click again. And I'm allowed to put in something else into Desmos. So Desmos already has our data set stored for us. And now we want to tell Desmos, hey, look, we don't just want it plotted. We want to find the line of best fit. And the way that you do that in Desmos is you're going to type in a y equals mx plus b equation. Now, the way that we do it is first, we're going to type in y. Okay, and I just typed that right in from my screen. I typed in y. Next, I want to put sub. The way that we do it in Desmos is you hold the shift button and then the button to the right of the 0 on your keyboard. That's the way that Desmos knows how to type in a subscript. And we want to type in 1. The reason why we're typing in 1 is we're trying to match the table that Desmos created. They called this x1, y1. So when we name our equation y equals mx plus b, we want to call it y1 and we want to use x1. So y1, I'm going to hit the right arrow all the way at the bottom right of your keyboard. So the right arrow. Next, I want to type in I call it the squiggly symbol. I think it's called a tilde. And where it is you hit shift and then the key above the tab button on your keyboard. Okay, so hold the shift button and then hit the key above the tab button. So I have y1 equals, next I want to have an m that represents my slope, mx plus b, right? So we need the x. Next I type in x, shift the button to the right of the 0, the subscript. We're going to type in a 1, hit the right arrow, and then we're going to type in plus b. Now, what Desmos is doing is it's drawing the line of best fit. If you look at the graph, those 5 points are not in a straight line. But what Desmos did is they said, well, let me draw a line that goes through most of the points, has the same number of points kind of above and below the line. It's if you had to draw a line to represent the data the best that you can, how would you draw that line? And that's what the line of best fit does. Okay, now I want to point out something that as we did this, Desmos automatically calculated the slope and the y-intercept. Your slope is down here. That's m. And your y-intercept, or your starting value, is right here. That's b. Now on IXL, if we go back to IXL, it's going to ask us to round our answers to the nearest thousandth to find m and to find b. So on this page here, I could see that m is 0.2. Looks like I have 0.006. 0.006. Well, rounded to the nearest thousandth, that means that we need to have 3 numbers after the decimal. So the 6 is going to tell the 0 to go up. So 0.201 is the slope. 0.201. I'm going to type that in. 0.201. Okay, the y-intercept is b. And that's this number here, 18.3679, which again, rounded to the nearest thousandth, is 18.36. The 9 tells the 7 to go up to an 8. So 18.368. 18.368. Okay, let me just tell you how to interpret this equation. Remember that B represents the starting value. So what they're saying is that based on their line of best fit, if you could have had a 0 over here, if we could have had a 0, what would the y value have approximately been? Well, this would have been 18.368. Okay. Now, the slope or the rate of 0.2 means that on average, as the x value increases by 1, the y value increases by about 0.201. And again, we noticed that before, that as the x values were increasing, the y values, for the most part, were also increasing. Okay, so there's our equation for the line of best fit, rounded to the nearest thousandth. Okay, now it says interpret the least squares regression line of this data set. So again, it has the same problem. We put this equation, which was correct, and now it says if stem and leaf agriculture increased the amount of the compound by 1 gram per bag, the least squares regression line predicts that the sunflowers would grow blank centimeters more per week. So what this question is asking is that on average, every time the x value is increased by 1, what happens to the y value? Every time the x value is increased by 1, what happens to the y value? Well, that's our rate. That's what the slope represents. The slope represents that the sunflower growth increases by 0.201 every time the compound increases by 1. Okay, so for this question here, they're really just asking you to interpret. They want you to realize that, hey, that's just what the slope represents. So we could type in 0.201. Okay, next, it's asking us to use our equation that we created. So here's the equation that we created for the line of best fit. And now it says, how much growth does this line predict if stem and leaf agriculture uses fertilizer from a bag that has 28 grams of the compound? So they're saying that if the x value were 28, what would your y value be? Well, we could use the equation that we created. Just going to copy down the equation exactly how it appears. And I'm going to make a substitution. The x value is 28. So when the x value is 28, we want to know what is the y value. We can use a calculator for this. There's a lot of decimals. Make sure that you're careful when typing in your calculator. 0.201 parentheses 28 plus 18.368. And I get 23.996. The question says round your answer to the nearest thousandth, and it's already in the thousandth place. So I'm going to type it in, 23.996. Okay, I'm going to do another problem with you. Let's go ahead and read this one together. It says, find the equation for the least squares regression line of the data described below. Every summer, the Milford Fair has a grasshopper catching contest. Grasshoppers are released into a fenced area, and participants are given 5 minutes to catch as many as they can. To even the playing field, the organizers developed a handicap system based on the results of this year's competition. The system takes into account the different experience levels of the contest participants. To create the system, the organizers recorded the number of times each contestant had previously participated, X, and the number of grasshoppers each contestant had caught this year, Y. And then they want us to write the equation for the line of best fit. Well, just by looking at the data, what you can see is that as the previous competitions entered increases, so as your X values increase, as they have more experience catching these grasshoppers, for the most part, what you can see is that the number of grasshoppers generally increases. Again, not always, but we're talking about a line of best fit here. So for the most part, as X increases, Y also increases. So we want to find the line of best fit. So again, using Desmos, I'm going to go ahead and clear these ones out. And we're going to enter in a new data table. I'm going to copy this. So highlight it all. Control C. Not sure if it got it there. I'm going to try it again. Control C. I'm going to go back to Desmos where it says 1. Control V. I'm going to paste it. And what it does is it takes our data table, and if you look, it actually plots it for you. Next, I'm going to go down to 2, and I'm going to type in the equation of a line using the way that Desmos wants me to type it in. So first I have Y, and I want to have that little sub 1 because that's what matches right here. So the way I do that on my keyboard is I hold the Shift button and then the button to the right of the 0. That's how I get a subscript in Desmos. I'm going to type in my 1, and then I'm going to hit the right arrow. If you don't hit the right arrow, do you see how the 1, you kind of stay small down there? You want to get out of that. You want to be on the same level as the Y. Next, I want to hold my Shift button and hit the button above the tab to make that little squiggly. And then I have M, X, Shift, the button to the right of the 0 is the sub button again. Type in 1. Once again, you see how I'm down on a lower level. I want to hit the right arrow to make it go a little bit bigger, to go back on the original level. And then I'm going to type in plus B. So once again, Desmos automatically graphs the line of best fit, and they give me the slope, also known as the rate, as well as the y-intercept, also known as the starting value. So I'm going to go ahead and make those values bigger so that way we could see them. So for M, we have 3 point, and again, I'm getting this from right here. So M is 3.2963, but IXL wants it rounded to the nearest thousandth. So the 3 is going to tell the 6 to stay the same. So it's 3.296 is your slope. I'm going to go to IXL, 3.296. Okay, for your y-intercept, that's B. B equals 9.01481, rounded to the thousandth place, 9.018. The 8 is going to tell the 4 to move up to a 5, so 9 9.015. 9.015. Okay, so now we have the line of best fit. Again, this is the same problem. We wrote the correct equation. Now it says the least squares regression line predicts that a participant would have caught blank more grasshoppers for each additional year of participation. So they're saying that as the x value increases by 1, what do we expect the y value to increase by? Well, that's what our rate represents. 3.296 is how many more grasshoppers somebody would be expected to catch for every previous year of experience. So this here is 3.296. Okay, next they're actually going to ask us to use our equation. So I'm going to go ahead and write the equation exactly how it appears. We had 3.296 x plus 9.015. Again, make sure for your calculation you use the rounded off answers here to the thousandth place. Don't use the original ones from Desmos. It says, how many grasshoppers does this line predict a 5-time participant would have caught this year? 5-time participant means that they had 5 years of previous experience. They're telling us that the x value is 5. We want to know how many grasshoppers would they have caught, which is your y value. So we're going to make this substitution. 3.296 times 5 plus 9.015. Again, use a calculator. We're just multiplying and adding, so you could use Desmos, you could use your own calculator. 3.296 times 5 plus 9.015. Okay, be careful about this one with the rounding. I get 25.495. Question said to round to the nearest integer. So 25.495, well, the 4 is going to tell the 5 to stay the same. So we're expecting somebody that's had 5 years of experience to catch about 25 grasshoppers. 25. Okay, once again, there's another question just like this, where you're copying and pasting the data set into Desmos, writing in the formula for y equals mx plus b, and then examining the rate and the starting value. Okay, good luck.